So in this video, we're going to just cover the principle behind solving simultaneous equations. So we're not going to solve any problems here. All we're going to do is try to get an understanding of simultaneous equations and how we go about preparing to solve them. Okay, so what are simultaneous equations? They're equations which have two variables, but they're a system of equations. So there's going to be two equations. For example, I might have something that looks like this. X minus 2y is equal to minus 6. And 5x minus y is equal to 6. So we're going to refer to this as equation 1. And we're going to refer to this as equation 2. So this is a system of simultaneous equation. What that means is that the value of x here in equation 1, once we have found it, is also the same value of x in equation 2. The same thing applies for y. Once we have found y in equation 1, it is the same as y in equation 2. So x minus 2y is equal to minus 6, and that same x and that same y, if you plug them into equation 2, 5x minus y is equal to 6 will come through. Okay, so what we have here is an equation in which we have x and y. Remember, those are called variables. So we have multi-variable equations here, right? Each of these equations has two variables, okay? So there are two methods that we're going to use to solve these simultaneous equations, right, at this stage. And those methods are elimination and substitution. Now, they work a little differently, but the concept is the same. And the concept is that we want to go from a multivariable equation to a single variable equation. So in the case of the method of elimination, we want to eliminate one of them. All right. So again, what we want to do is you want to move from a multivariable to a single variable equation, right? So here we have an x and a y in this equation, and we have an x and a y in equation 2. So if we could eliminate the x or eliminate the y, and then we can then work with a single variable equation. So that's the concept behind the method of elimination. So for argument's sake, at this point here, what I'm going to do is this line right here means I'm going to add these things. But if I'm going to eliminate, then I probably want to have a minus 5x right here, right? That way I'll have a minus 5x and a positive 5x, and then I could cancel them. So I ask myself, how do I get a negative 5x here? Well, I could multiply this by negative 5. See? But I can't just multiply the x. I've got to multiply everything in the equation. But the purpose of doing any multiplication here is because I want to get to a point where I can eliminate. Okay, so that's how I get to choose what I'm going to multiply by and what equation I'm going to do my multiplication to. There are cases where you multiply both equations. For now, we're just dealing with the concepts, okay? When we start working with examples, we'll work with examples that show that sort of stuff, okay? So if I multiply equation 1 by negative 5, okay, what I'm going to end up with is negative 5 times x, negative 5 times minus 2y, negative 5 times negative 6. Now I do nothing to equation 2. And you will realize then that when I multiply minus 5 by everything in equation 1, this is what I'm going to get. Negative 5x, positive 10y, and a positive 30. Again, I did nothing to equation 2. So I just bring this down here. And what I'm going to do here is I'm going to add. Okay? I'm going to add. So when I do that, I realize that negative 5x and positive 5x, in fact, cancel each other out. And so you realize then that we have eliminated the x variable. Now I come here and I finish this up. This is 10y minus y, so this is 9y. is equal to 30 plus 6, which is 36. And clearly we can solve this. This is a single variable equation at this point. All right, now, and we're not solving problems in this video. We're just trying to get the concept here. So this is a point where you pause it and you consider, did I learn anything here? Okay, go back, rewind, go again. All right, take a look at this and see if I learned anything here. In our subsequent videos, we're actually going to work problems, okay? So as I mentioned earlier, there are two methods for solving simultaneous equations that we will be working with. The first, as I just explained, is the method of elimination. And the second is the method of substitution. And the concept is the same, right? We want to move from a multivariable to a single variable equation, right? So what I want to do here is I want to write one variable in terms of the other, okay? So let's start with that same problem that we had just now, okay? So I had x minus 2y is equal to minus 6. And then I had 5x minus y is equal to 6. So again, this is a system of equations, okay? Simultaneous equations. So take a look right here. What am I trying to do? I'm trying to write one variable in terms of the other. Let's make some sense out of that. Let's take equation 2, and we could take equation 1 or equation 2, right? But you know what? Let's take equation 1. Let's take equation number 1, right? So I have x minus 2y is equal to negative 6. So if I want to write x in terms of y, that's another way of saying make x the subject of the equation. And when I want to make x the subject of the equation, what it means is that I want to end up with something that looks like this. X is equal to something, which means x has to be on a side by itself, which means this right here, even though it's a variable, it's not x. So I want to transpose that. And I really and truly already understand what that means. It means take it on the other side. And whatever sign it has, it will flip. So now when I do that, I get x is equal to positive 2y. So I just write 2y minus 6. See, so now I've written x in terms of y. How is that useful? How is that useful? Because now what I'm going to do is I'm going to substitute that. Substitute x is equal to 2y minus 6. Now, this is where I have to be careful. I've got to put this into the equation that I did not use to find it. So I found x by using equation 1. So now I've got to put this into equation 2. So what do I mean by put it into equation 2? Okay, well, equation 2 says 5x minus y is equal to 6. But I already have an expression for x. So wherever I see x, I'm supposed to have 5x. Wherever I see x, I'm going to put this expression right here. See that? Wherever I see x, I'm going to put 2y minus 6. And then, so that's 5x minus y is equal to 6. So again, what I have here is I have an equation that has one variable in it. See, it's y and y. There's no x. Of course, I have to do the math here, and we're not really going to solve this problem. Just to give you an idea what would happen, you'd multiply 5 times 2y, so you would end up with 10y minus 30. 5 times negative 6, and then minus y is equal to 6. And so, of course, you would then take this right here. This is a constant. And you would transpose it, bring it over here. Okay? And then you would put the y's together and solve and go from there. So, again, this is just the concept. All right? This is the principle. And you want to make sure you grasp the principle really clearly. You want to grasp the principle really clearly so that we can move forward and actually solve some problems. Okay? I hope you enjoyed the video. I hope it was helpful. Please hit a thumbs up, and more importantly, share with your friends. Okay. Other videos in this and other series are available. Like, share, and subscribe if you found the video helpful. If there's a topic you'd like to see us tackle, just let us know.